Good morning. Today we are going to see how do we design an ATM machine using ESP32. Here we can see the connections where the pin numbers 32 to pin number 13 are used are the touch pins and they are used as input pins, and here the pin number 4 and pin number 15 are used. In between these pins, pin number 26 and pin number 27 are not touch pins, and thus we have connected a push buttons so that we can take the input from the user for those pins. Now coming to the code. Now, now coming to the code starts from the inclusion of the header files and the SSID and the SSID and password. Then we give the server name, initialize the Telegram bot, and then we declare the number of denominations of the different types of nodes as well as the balance. I have used a variable called logged in to decide whether the user is logged in or not. Then that function touch inp, what it does is it checks the status of all those pins and it gives us whether the input is available in those pins or not. Then if the text is logged in, we generate an OTP, and then the OTP is printed in the Telegram bot, which the user should enter using the touch pins, which would be verified to check whether the user is correct or not. Then a high to low signal is sent with a delay of 2 seconds on the onboard LED of the ESP32, so that we get an output in a visual format whether the user is logged in successfully. Here the logged in variable is set to 1 if the OTP is proper, and else the logged in is set to 0. Now in the withdraw function, what we can see is that the user is not logged in. We send a message that you are not logged in and thus you need to log in to continue. But if the user is logged in, we check his available balance and send the balance, and we check the amount to enter using ESP30 amount he needs to withdraw. The number of digits is taken as an input, and then those number of digits are taken which are multiplied so as to get the total amount in a numerical format. Thus we check if the amount is less than 500, and since the least denomination we have is 500, thus the minimum withdrawal amount should be 500. And if the amount is greater than the balance of the user, then the user cannot withdraw such a high amount. Then we check the denominations required for the amount, and thus we give the output as how much amount was withdrawn and the denominations of those notes. In the balance function as well, we check whether the user is logged in or not, or else prompt him to log in. Then in the setup function, we begin with a serial monitor and then connect with the Wi-Fi. Then set up the pin modes as input. Here the input pull-up mode is used because the push buttons require a pull-up register, and input pull-up would activate the inbuilt register of ESP32. In the loop function, we check for new messages, and we also keep checking for the number of the nodes of different denominations, and keep updating it in the ThinkSpeak API. Now, as we come to ThinkSpeak, as we can see, I have created an account on ThinkSpeak, and I have created 4 different channels. I have created a channel in which there are 4 different fields, each one for 2000 rupee notes, one for 1000 rupee notes, one for 500 rupees notes, and one for the balance. Initially, these values are the actual values, which are 5, 10. Here the feed is taking some time to reload, and here the value is 25. To the ESP32 board, if we say /start, it gives us the available commands, which are login, withdraw, and balance. Now, without logging in, if we directly say withdraw, it notifies us that you are not logged in and please log in to continue. Similar for the balance conditions. As we can see, it says you are not logged in. Now, let us try to log in using the OTP. Now the given OTP is 62 and it keeps checking. Now so if we come to the ESP32 and here we see that the pin number 6 is connected, the number 6 is connected here, but we have got a delay in the OTP, and we have got delayed in entering the OTP, and thus it says the verification is failed. Now if we try once again, now the OTP is 71 and let us try to enter the correct OTP. Now because of the touch functions we have several different errors in the OTP, but now we have got OTP as 23 and let us try 2 and then 3. Now we need to get a right OTP. As we can see, due to the touch function, we have several failed attempts of OTP enters. But for OTP 50, we have successfully verified ourselves and we have logged in. Now we can, after successful login, we can try to withdraw our amount using the in the ESP32 using the withdraw command, and let us try for the number 1500. Thus, the number of digits input should be 4. After entering the number of digits as 4, we can enter our number as 1500, which would be 1 5 0 and 0. First we enter 1 and then we enter 5 and then we enter 0 and 0. Now since we entered 1500, it shows the amount to withdraw as 1500, and then it shows us the withdrawed amount, the number of notes of various denominations, and the remaining balance. This would be updated in the ThinkSpeak account after some time, after a few minutes. But till then, we can also check our balance. See, it shows the remaining balance as 23,500. We can ThinkSpeak. These are the initial denominations shown to us, and as now we can see, the 500 notes are also visible. The count of the 500 notes are also visible, and after a few minutes, after a few refreshes, it would also show the exact amount of notes available at a particular instant. Thus, we have seen how do we make how do we make an ATM using a Telegram bot and help users withdraw their amount after successful verification of their login, as well as the balance check and the uploading of the data on the ThinkSpeak crowd under numeric widget.